Welcome back, guys, to another lecture where we'll be looking at another example on random questions on polynomials and functions. Now, this particular example will be linking our idea of polynomials with our idea of functions. So it will be showing us the relation between all these because they are actually under a particular umbrella topic. So we'll be looking at how how a question can actually relate these two subject matters together, and then follow through, and then you'll get the concept of what we're actually doing. Now we have an example here. It says a polynomial f of x is defined in terms of the constants a, b, and c as f of x equals to 2x cubed plus ax squared plus bx plus c, such that x is an element of R. It is further given that f of 2 equals to f of 1 and then is equals to 0, and f of 1 is equals to 14. And we are asked here to find the values of a, b, and c. So the first thing we have to do here, as usual, is to bring out our parameters, our function, our polynomial. That is, we have f of x equals to 2x cubed plus ax squared plus bx plus c. So in this case, you have a polynomial having three unknown values. That is, we have our a, we have b, and then we also have c. Three values that we need to know their values before we can actually move on. So in order to do that, the first thing we have to do is, to find our a, b, and c, we need to compare with other information that we have been given. We have also been given that f of 2 equals to f of 1, f of minus 1 rather. We're also given that f of 2 equals to f of minus 1 equals to 0. And we also heard, and we're also told that what f of 1 is 14. So these are the two other information we're given. So in order to relate with this, from our idea of function, from our idea of basic functions, we remember that when we have f of 2, where we are given a particular function f of x, we are supposed to actually substitute our value of 2 into the function, then express the function in as you substitute into the value and then simplify the function. So for f of 2 now, f of 2 here will be 2 into brackets 2 raised to power 3 from the original function plus a into brackets 2 squared plus b times 2 plus c, of which they have already told us that f of 2 will definitely give us 0. So equating this to 0, this is what we get. So moving forward, we have 2 into bracket 8 plus 4a plus 2b plus c equals 0. From here, I know this is 4a plus 2b plus c equals to minus 16. From our knowledge of linear equations, now I have collected my like terms. I have my a, my unknown b, my unknown c, and then I took my constant value to the other side of the equation. So having this as the first equation, I regard this as what? As an equation 1. I can regard this as an equation 1. Moving forward, I've considered my f of 2. So the next thing I can consider is also my f of minus 1. The f of minus 1, substituting minus 1 for x into the original polynomial, we have 2 into bracket minus 1 cubed plus a into minus 1 squared plus 2b. Sorry, and we have substitute our plus b into minus 1 plus c equals to 0. Simplifying this the same way we did the other, this becomes 2 into minus 1 plus a into bracket 1 plus b times minus 1 gives us minus b. So we have minus b plus c equals to 0. From here, simplifying this, I know I get a minus b plus c is equals to 2, since we have minus 2 here, and then when we take to the other side, it becomes 2. So this is our equation 2. Moving forward, we look at the third one. F of 1 is equal to 14. So for f of 1, I can say for f of 1 now, f of 1 is 14. Can easily substitute my 1 for x in the polynomial. 2 raised to power 1, 2 times 1 raised to power 3, plus a into bracket 1 square, plus b into bracket 1, plus c equals to 0. So I know, what do I need to do here? I just need to expand. We have 2 into bracket 1, plus a into bracket 1, plus b, plus c equals 0. Simplifying this, I have not 0 this time, but then it will be 14 because that's what our f of 1 was given to us as. Said it's equals to 14. So equating both of them, you have equals to 14. You have a plus b plus c equals to 14 minus 2. So I know my equation here becomes a plus b plus c equals to 12. It becomes my equation 3. Now I have 3 equations I can play with. My first equation here says 4a plus 2b plus c equals minus 16. 4a plus 2b plus c equals minus 16. The second one says a minus b plus c equals to 2. And the third one says a plus b plus c equals to 12. Now I can use a series of methods. To actually solve this question because this is obviously a simultaneous equation. Simultaneous equation with 3 variables, and then because it's 3 variables, we have 3 equations to solve them, thereby giving us 3 different answers. That is for a, b, and c. So if I was to, by simple substitution, I can from equation 1, this is from equation 1, we can derive that c is equals to c here would give us minus 4a minus 2b minus 16. That is, if you make c the formula in your equation 1, you take this 2 to the other side, you get this. And then you can substitute this value. Then substituting, you can call this equation 4. And substituting equation 4 into equation 2, we'll get another equation that will actually now simplify things for us, where we'll have a minus b plus our c here is minus 4a minus 2b minus 16, which is equal to 2. So if that's the case here, I can easily now say from here, I can say this a, opening the bracket here, I have a minus b minus 4a minus 2b minus 16 equals to 2. And I have a minus 4a here gives me a minus 3a minus 3b equals to 2 plus 16. I can multiplying through by minus here, I'll have 3a plus 3b equals to minus 18. If I divide through by 3, since 3 can go in each of them, I'll have a plus b equals to 6. I can call this one equation I. Since this one, I've already broken down my equation to one that will just have 2 variables and I can relate with it. Now, I've taken that one, I need to get an equation II so that I'll be able to relate with only 2 variables, and then once we are done with that, we can substitute and get the third variable. So let's relate equation 2 and equation 3 together. Relating equations 2 and 3, we know from equation 2 we have a minus b plus c equals to 2. a minus b plus c equals to 2. And we also know we have a plus b plus c equals to 12. A plus b plus c equals. I can easily want to eliminate my c. By eliminating c, I can subtract both equations, and then by subtraction, I have a minus a gives me 0. I have minus b gives me minus 2b. And then I have c minus c as eliminated also. And then I'm left with 2 minus 12 gives me minus 10. And from here, I can get my value of b by dividing both sides by minus 2. And I have b equals to minus 10 over minus 2. My b therefore gives me a value of 5. Since I've gotten my b, I can actually now substitute to get my a from equation I. So I can say, I just put my value of b, put b equals to 5 into equation I. So substituting that into it, we have a plus 5 equals to 6. From here, I can deduce that my a here will be 6 minus 5, which will consequently give me a value of 1. So I've gotten my a. I know the next thing on my bucket list now is to get my value of b. So I can decide to take from any of the three equations, the three major equations, and substitute my a and b in any of them so that I can get my c. So if I'm taking from equation 2, then from equation 2 now, from equation 2, we remember that a minus b plus c was given as 2. So if a minus b plus c is given as 2, and I've gotten my a value to be 1, I've gotten my b value to be 5, I want to get my c here, so I can easily solve, and then I have c minus 4 here, gives me 2, then my c here becomes 4 plus 2. It just means that my c value is 6. So I've gotten my a, I've gotten my b, and I've gotten my c. So therefore, a equals 1, b equals 5, and c equals 6. So this is a typical question relating the idea of functions to polynomials. So if you are able to do this, believe you me, there is actually nothing that will actually give you problems under polynomials and functions. So in the next class, we'll be looking at mapping as a subject matter, as it relates to functions and polynomials. So see you next class. Have a nice day.